This is Jacob's Algebra, Chapter 13, Lesson 2, Part 2. So at the end of the Part 1 video, we had just finished determining the data tables for the equations in number 6, parts A, B, and C. The equation for Part A was y equals x squared. For Part B was y equals x squared plus 6. And for Part C was y equals x squared minus 4. Now, we first did the data table for y equals x squared. So we chose values for x. I chose -4, -2, 0, 2, and 4. And then we squared each of those values to get our y. For part B, since our answer was x squared plus 6, we already had x squared. All we had to do was add 6 to it. I chose the same values for x, so I could take the values I already had for x squared and just add 6. And then for part C, our equation was x squared minus 4. So again, I went back to our original values that we calculated for x squared and just subtracted 4 for each one of them. Okay, so now let's take a look at what the graph looks like for this. This is what the graph is going to look like for number 6. I want you to notice how all of the graphs have the same shape, how they are all graphed on the same axes, because number 6 asks that you graph them all on one pair of axes. And then it asks, what do you notice about these three lines? Okay, part A is y equals x squared. This is my graph for part A. You can see how it's a curve. And the turning point of that curve is right here at the origin. That's at 0, 0. Okay, now I'm going to move this over. For part B, our equation was y equals x squared plus 6. That's going to be this curve right up here at the top. And I want you to notice that where the graph turns around, where it goes from being a downhill function into an uphill function, is at y equals 6. And then for part C, we have y equals x squared minus 4. And that's going to be this bottom curve, which you'll notice has the same shape as our other two curves. And notice what it does. Its turning point is down here at -4, which is what we ended with over here. So if we look at our original, which was y equals x squared, our y equals x squared minus 4 is 4 units lower. Our y equals x squared plus 6 is 6 units higher. Okay, so that's all that this question was asking for. Really, for part D, what do you notice about the three graphs? It's really just looking for you to say they're all the same shape, but I wanted to give you just a little bit more information than that. Okay, so let's look now at problem number 7. Problem 7 is just like problem number 15 that I assigned for homework. It says graph the following functions, each on a separate pair of axes. Let one unit on each y-axis represent 10. So this is going to be very similar to number 6, except we're going to graph these each on a separate pair of axes. Okay, so I am going to graph for 7a. I've got x, and then I'm going to also graph my y. So here's my x. And then for y, I'm going to have y equals x cubed. So I'm going to start with -4 and then do -2, 0, 2, and 4. -4 when we cube it is -64. Here's where you got to be very careful. When you raise a negative number to an even power, you will always get a positive number. But when you raise a negative number to an odd power, you will have an odd number. Odd powers keep whatever sign you originally had, and odd power will keep it. An even power will always be positive. Okay, so then we need to take -2 and cube it. -2 cubed is -8. 0 cubed is 0, 2 cubed is 8, 4 cubed is positive 64. So now we have our values for x and y, where y equals x cubed. Now let's look at part B. Part B, we need to choose values of x, and then our y is going to be y equals 2x cubed. Oh, hold on, I didn't switch to pen mode yet. Okay, so y equals 2x cubed. And I'm going to do something a little bit different here, because when I did -4, my value was too big. So I'm going to do -3, -2, 0, 2, and 3. Because for -3 and for +3, my numbers would be too big. I'm sorry, for -4 and +4, my numbers would be too big. So -3 cubed is -27. And when I multiply that by 2, I get -54. -2 cubed is -8. When I double that, I get -16. 0 cubed is 0. When I double that, I still have 0. 2 cubed is 8. When I double that, I have 16. And then down here at the bottom, 3 cubed is 27. When I multiply that by 2, I get 54. So those are my data points for the equation in part B. Now let's look at part C. Part C has another equation. Draw my grid lines. Okay, for part C, we have x, and then y is equal to 1/2 x cubed. Okay, so now I'm going to choose different values of x. I'm going to go back to my original values, -4, -2, 0, 2, and 4. And this time I'm going to have 1/2 of x cubed. Well, I already calculated x cubed over here for part A. So for -4, what is 1/2 of -64? That's -32. What is 1/2 of -8? That's -16. 1/2 of 0 is still going to be 0. 1/2 of 8 is going to be, oh wait, I said 1/2 of -8 was -16. 1/2 of -8 is -4. And then 1/2 of 8 is 4. And then 1/2 of 64 is going to be 32. So this is the data table that I constructed for this problem. Then you have to graph each of these on a separate axis. These are not graphed all together. These are graphed separately. So let me see. First off, here is number 7, part A. Let me stretch this up a little. Okay, so number 7, part A. Notice that in the instructions for number 7, it said let one unit on each y-axis represent 10. That's why my y-axis is number 10, 20, 30, 40, 50, 60, 70, because it said to let each square count for 10 on the y-axis. My x-axis, each square just counts for 1. And so you can see what I have graphed here. I'll move it out of the way here. I should have the point -4, -64, and here's -4, and that's about -64. -2, -8, here's -2, and that's about -8. 0, 0, 2, 8, and 4, 64. Okay, so now let's look at a graph for part B. For part B, let me make this bigger. Okay, so for part B, we have this graph here. You can see that we still cross through the origin. The difference between this graph and the last graph is that it's taller and skinnier than the last one was. And so now let's look over here at part C. This is 1/2 x cubed. You'll notice this one is wider than the last one was. Okay, so now let's look at another problem. It says graph the following functions, each on a separate pair of axes. And there are 4 problems down here. I'm just going to take a look at 2 of these. So let's look at number 10. For number 10, the equation is y equals 10x cubed minus, no it isn't. Okay, let me fix that. Okay, so the actual equation is y equals x cubed minus 10x. There was a 10 in it, I just had it in the wrong place. So y equals x cubed minus 10x. So what we need to do is create a data table. So I'm going to just draw lines here so I can make a data table. So I'm going to write my x's on the left side. On my right, I'm going to put y equals x cubed minus 10x. And for number 10, the values we're going to choose for x are -4 to +4. So we've got -4, -3, -2, -1, 0, 1, 2, 3, and 4. I did tell you on each one of these problems what values to use for x. That's in the homework email that I sent out on Monday. So make sure you check that to see what values to use for x. I gave you values that would all graph nicely. Okay, so looking at number 10, again, we have our x values written on the left side, and we need to figure out what y is. So negative 4 cubed is negative 64, and then minus 10x. 10 times negative 4 is negative 40. We're subtracting a negative 40, so that means we're adding 40. That's negative 24. Be very careful of your signs here. Negative 3, when we cube it, is still negative. It's a negative 27. And then minus 10 times 3, 10 times negative 3, remember a negative times a negative is a positive, minus a negative 30. And then negative 27 plus 30 is 3. So I'm going to pause this to put the rest of these values up. Okay, so what you see here now is I went ahead and just wrote down the rest of the values for number 10 rather than taking the time to work each one out separately. Remember, when you have a cube, be very aware that the sign you started with is the sign that you will end with. When you cube a positive number, you end up with a positive number. When you cube a negative number, you end up with a negative number. It's not like squares. With squares, you always end up positive. With a cube, if you started positive, you'll stay positive. If you started negative, you'll stay negative. Also remember that when you subtract a negative number, that's the same as adding. Minus a negative is the same as plus. So now let's take a look at what this graph looks like. Okay, so you can see here, this was our graph for number 7C. And whoops, this is 8 and 9. Okay, let me get graph for number 10. Okay, so here we go with number 10. And you can see this is a very different graph from the other graphs we've done. This one turns around twice. That's because it's a cubic equation. I want you to notice the degree is 3, and look at what happens here. It crosses the x-axis 3 times. We're going to look into that more later, but that's something to notice here. It changes direction more than once, and so that is our graph for number 10. Now let's move on and look at number 11. Number 11 says, uses the equation y equals x to the 4th plus 2. So again, we're going to set up a data table with x and then y equals x to the 4th plus 2. So let me draw my lines. Okay. So again, we need to choose values of x. What I chose was negative 2, negative 1, 0, 1, and 2. And I'm going to plug this into our equation. Negative 2 to the 4th is going to be a positive 16 because a negative raised to an even power is going to be a positive. And then we have plus 2. So 16 plus 2 is 18. Negative 1 to the 4th power is a positive 1 plus 2 is 3. 0 to any power is still 0, plus 2 is 2. 1 to the 4th power is 1, plus 2 is 3. And then 2 to the 4th power is 16, plus 2, that is 18. So now we can graph this. And when you look over here at the graph for number 11, you can see we get kind of a more rounded version of the same kind of graph we had when we just had x squared. So that is it for this. I want you to be very aware that if you go back to the original homework email, I give detailed information about what values you need to use for x so that you will have a reasonable graph and so that you will actually graph the portion of the curve that we're really interested in. Be aware that for number 14, you're going to graph all 3 of those equations on the same axes. And then for number 15, 16, 17, 18, and 19, those are all separate graphs.